Given f of x equals negative 3x to the fourth plus 39x cubed minus 165x squared plus 225x, and knowing one factor is x minus 3, write f of x in factored form and then give the zeros of the function. Looking at the function carefully, notice not only is x minus 3 a factor, but so is x because each term contains at least one factor of x. Let's begin by factoring out x from the polynomial function. We can write f of x as f of x equals x times the quantity negative 3x cubed plus 39x squared minus 165x plus 225. And then from here we also know x minus 3 is a factor, which indicates x minus 3 must be a factor of this cubic factor. So now we can write the polynomial function in the form of f of x equals x times the quantity x minus 3 times some remaining degree 2 or quadratic factor. To find the remaining degree 2 quadratic factor, we will now divide the degree 3 factor by x minus 3 using synthetic division. Recall when dividing by x minus 3, we use the 0 of positive 3, and then we list the coefficients of the polynomial. And again, we're dividing the degree 3 factor by x minus 3, not the original polynomial factor. And therefore the coefficients are negative 3, 39, negative 165, and 225. And because x minus 3 is a factor, we should get a remainder of 0. To begin, we bring the negative 3 down, then multiply by 3. Negative 3 times 3 is negative 9, and then we add 39 plus negative 9 is 30. Multiply by 3. 30 times 3 is 90. Add negative 165 plus 90 is negative 75. Multiply by 3. Negative 75 times 3 is negative 225, and we do have a remainder of 0. This indicates the remaining quadratic factor is negative 3x squared plus 30x minus 75. From here, notice the given quadratic factor has a common factor of 3. Let's go ahead and factor out negative 3. We can now write the given polynomial function as f of x equals negative 3x times the quantity x minus 3. And again, we're factoring negative 3 from this quadratic factor, which gives us positive x squared minus 10x plus 25. Notice if we distribute the negative 3, we still have negative 3x squared plus 30x minus 75. And now let's factor x squared minus 10x plus 25. If it does factor, it will factor into two binomial factors. The factors of x squared are x and x. Now we want the factors of 25 that add to negative 10, which are negative 5 and negative 5, giving us two factors of x minus 5. Because we have two factors of x minus 5, let's write this as the square of x minus 5. The factored form of the polynomial function is f of x equals negative 3x times the quantity x minus 3 times the square of x minus 5. And now to determine the zeros, we set each of the factors equal to 0 and solve. We can ignore the negative 3. One of the zeros is x equals 0. X minus 3 is equal to 0 and x equals positive 3. And x minus 5 is equal to 0 and x equals positive 5. The question doesn't ask about multiplicity, but if it did, because we have two factors of x minus 5, the multiplicity of the 0 x equals 5 would be 2. The remaining multiplicities for 0 and 3 would be 1. So the zeros, again, are x equals 0, x equals 3, as well as x equals 5. Notice counting multiplicity, we did find 4 zeros because we have a degree 4 polynomial. Before we go, let's verify the zeros by analyzing the graph of the polynomial function. Recall the real zeros appear as x-intercepts of the polynomial function. Analyzing the graph of the polynomial function, notice The x-intercepts are 0, 0, 3, 0, and 5, 0, which verifies these zeros are 0, 3, and 5. Notice for these x values, the y values or function values are 0. Notice where the multiplicity of the zeros are 1, the graph cuts through the x-axis, but where the multiplicity is 2, at x equals 5, the graph touches the x-axis and then bounces back, or is tangent to the x-axis at that location. I hope you found this helpful.